Assalamualaikum warahmatullahi taala wabarakatuh. And then we continue our lesson today. So today we need to understand the work done. The work done by a gas or on a gas. Okay, so we refer to the diagram here. So this one is a piston and then contain the dot is as a molecule of gases. And here is a piston and then it contain a molecule of gas here. And then so we have the VI as a initial volume and then of course the VF as a final volume. So and then same with this diagram, VF final volume, VI is a initial volume. Okay, and then the heat is supplied to the piston. So the heat supplied to the piston and then what happened? So the piston expand the volume. So from the VI to the VF. So that's mean the work done by a gas, then what happened? So it's shown here increasing in the gas volume. Okay, this one for the expansion of the gas. If we refer to this diagram, so in this case we supply the heat and then in this case is the work done on the gas. So work done on the gas and then in this case is a compression. So compression does mean the decreasing in the volume of the gas from VI and then decreases to the VF here. What we can saw here. Okay, so decreasing the gas volume. So that's what is your compression. Okay, so work done on the gas. For the expansion, work done by a gas. Okay, so then we continue so to get the equation of the work. So equation of the work, so we refer to the diagram. Q heat is supplied and then absorbed by the molecules of gases and then what happened? So the volume of the piston is increasing. So from here they are increasing to here. A is the cross-sectional area of the piston and then F is the force. Okay, so from the mechanics pressure, P is equal to the F over A, F is equals PA, and then from the equation of the work is equal to the applied force delta X. So F, we replace the F as a PA delta X and then the PA is as a change in the volume. Therefore you can write as a P delta V. So your work for the equation is W is equal to P delta V or P is equal P bracket V final minus V initial. So that means the work we can write as a P. So the V final minus the V initial. This one is the equation for the work by or on the gas. Okay, P is a pressure. Okay, so we continue. So here is the and then here. So this one is the equation of the work. So work, we have two type of pressure. So pressure is not constant and then pressure is constant. Then how we can apply this equation for the P is not constant, P is constant to get the work done by or on the gas. Okay, so we go for the P is not constant. So we have the delta W is equal to the P delta V, and from the ideal gas equation PV is equal to the nRT. This one is the ideal gas equation. Then we rearrange the equation, we can get the P is equal nRT V. And then we continue. Delta W is equal, so we replace the P here. Then we can get the nRT over V delta V. So we rearrange the equation, then we have the delta W is equal nRT delta V. nRT is a constant one. And then we apply the integrated, so both sides. So for this side and then for this side, then we can get, at last we can get this equation. nRT ln V refer to V final and then the V initial. Okay, then we can write the equation for the work. W is equal to nRT ln V final over the V initial. This is correct for the P is not constant. Okay, so and then so we can get the work nRT ln V final V initial for the P is not constant. So this one is the graph for the P is not constant. This one for the expansion. Here for the compression. Okay. And then we go for the next. If the P is constant, for the P is constant, W is equal P delta V, P V final minus the V initial. P is constant. So P is constant, so the equation is look very simple. So that means we still can apply this equation. You know the P, then you know the V final, you know the V initial, you apply to this equation, you can get the work done by or on the gas. So here is the graph for the P is a constant. So area under the graph is referred to the W. So this one for the case expansion, this one is for the case compression. See, compression that means is decreasing in the volume of the gas. Okay, so here is for the P is constant. P is not constant, we need to apply this equation. W is equal nRT ln V final over the V initial. Okay, P is constant, straightforward, apply this equation. W is equal to P V final minus the V initial, then you can get the answer. So for that, thank you very much.